Today we're going to be talking about what are called the power reducing formulas. Now these power reducing formulas, what they allow us to do is to go from an angle, a trig function of an angle squared to just the trig function of an angle. So it can get rid of the square root, the second power, without square rooting, because if we try to square root something, we have to square root the whole thing. We can't just square root part of it. We have to square root everything on both sides of the equation, and that can make things more confusing, more difficult. So instead, we have what are called these power reducing formulas. And these are also on our cards, our green sheet. So, but I also have them up here for our reference. So they can be derived from the double angle formula, because remember yesterday the double angle formulas had a squared in it. Okay, like cosine of 2x is equal to 2 cosine squared x minus 1. So using that fact, we're kind of going in the other direction and getting the squared part by itself. So we can, like I said, derive those from the other formulas. We're not going to do all of these because it's just showing why the formulas work, but it is neat to see. So if we subtract 1 from both sides, we get cosine of 2x minus 1 equals negative 2 sine squared x. And then divide both sides by negative 2. So we get negative cosine 2x plus 1 over 2. And then we can rearrange the numerator to make it 1 minus cosine 2x over 2. And like we said, that is the same formula as we have up here, what sine squared is equal to. So instead of verifying the other ones, we're just going to start using them. So it says rewrite the expression in terms of the first power of cosine. Okay, so we want cosine to the first power. So right now we have cosine squared of 2x. And again, our formula is cosine squared of x is equal to 1 plus cosine 2x over 2. We may say the difference here is we have 2x right here. Okay. As our angle is 2x, we're still going to multiply that by 2. So using the power reducing formula, we get 1 plus cosine of 2 times our angle, which is 2x, over 2, which is equal to 1 plus cosine of 4x over 2. Now, what we want to do is we want to have, we don't want to deal with dividing by 2, so we're actually going to factor out a 1/2. So we factor out a 1/2, that gives us 1 plus cosine 4x. And we can distribute this to verify that we get what we started with. So we now reduce this to a cosine to the first power. So this is our final answer. Now letter B is sine to the fourth power. So you have sine of x to the fourth power. Well, this is really equal to sine squared x squared, because the power reducing formula only works with sine squared, cosine squared, or tangent squared. So sine squared is going to be 1 minus cosine 2x over 2. So let's rewrite that. So instead of sine squared, it's going to be 1 minus cosine 2x over 2 squared. So I replaced this with the power reducing formula. So now we're going to square the top and bottom. So if we square that top and bottom, we get 1 minus cosine 2x times 1 minus cosine 2x over 4. So we're going to FOIL the numerator or use the shortcut. 1 minus 2 cosine 2x plus cosine squared 2x over 4. Well, the directions said do cosine to the first power. We have a cosine squared right here, so we're going to have to power reduce this. So we're going to power reduce that while also factoring out a 1/4. So 1/4, 1 minus 2 cosine 2x plus 1 plus cosine of 4x over 2. Because remember, the power reducing formula takes our angle and multiplies it by 2. Our angle is now 2x, so 2x times 2 is 4x. All right, so now I'm going to rewrite this and factor out a 1/2 again. But when I factor out a 1/2 from these two terms, I'm actually going to be multiplying those by 2. So 1/4 times 1/2, oops, let me rewrite this, times 1/2 times 2 minus 4 cosine of 2x plus 1 plus cosine of 4x. Because if I were to distribute this 1/2 back in to everything, okay, I get exactly what I had up there in the previous step. So if I'm factoring out a fraction, you can actually multiply the terms that you're factoring out of by the reciprocal. So I'm factoring out a 1/2, so I got to multiply everything by 2. I can combine these terms into 3 and multiply 1/4 and 1/2, so you have 1/8 times 3 minus 4 cosine 2x plus cosine of 4x. And we have cosine to the first power, so we are done. So letter C, we have cosine squared x times sine squared x. So we're going to power reduce both of these. Cosine squared x power reduces to 1 plus cosine of 2x over 2. And then sine squared power reduces to 1 minus cosine of 2x over 2. So this reduces to that, or changes to that, and this changes to that. So now we can multiply these. Now the numerator, it's going to be nice because we have 1 plus cosine 2x times 1 minus cosine 2x. So that's the difference of two squares in factored form, so we can just multiply the first two and the second two. And then we are going to multiply the two denominators. So I'm going to factor out a 1/4, but also power reduce the cosine squared of 2x. So 1/4, so we have 1 minus, now cosine squared 2x power reduces to 1 plus cosine 4x over 2. And we want to put parentheses around it because we want to be mindful that the negative should go into everything, because we change this to all of that. So that negative sign in front needs to be distributed. So that's why I put parentheses around it. So I'm going to distribute the negative now. So 1/4 times 1 minus 1/2 minus cosine 4x over 2. And I also split up the fraction. So instead of 1 plus cosine 4x, when I distributed the negative, I made it two separate fractions. So then I'm going to factor out a 1/2. So 1/4 times 1/2. And we get 2 minus 1 minus cosine of 4x. 1/4 times 1/2 is 1/8. And then 2 minus 1 is 1. So it's 1/8 times 1 minus the cosine of 4x. And that would be our cosine to the first power. So just like with the other stuff we've done in section 5.5, using the formulas and making the substitution isn't hard. It's the simplifying and condensing and the algebra that is probably going to give us most of our issues. So yeah, that's it for today. We're just using this power reducing formula, and we may have to use it multiple times, but that's okay. We just keep everything consistent, and we'll be fine. So thanks for watching. Make sure to like the video and subscribe.